First one. Now we said our strategy. Now, the problem is I'm talking over people right now. I don't want to do that anymore. I'm just talking louder and louder. I don't really need to. So if I'm talking over you, please stop. Okay, multiply coefficient times coefficient. So if I'm looking at this first problem, I'm a little bit irked because I don't see a coefficient on the first one, right? It's just the square root of 8. What's the coefficient? 1. Put a 1 if you want. That's fine. Put a 1 if that helps. When I don't see a coefficient, I can always put 1 as the coefficient. This is 1 times the square root of 8, 5 times the square root of 2. Okay, so I'll do coefficient times coefficient. 1 times 5 is 5. Radicand times radicand. 8 times 2, so that's the square root of 16. So I just did multiply the coefficients, multiply the radicands, simplify the radical if needed. Now, some of you guys will go and you can make a birthday cake for 16 if you would like to do it that way. Certainly not wrong. But what's the square root of 16? 4. We don't need a cake for that necessarily, right? I mean, if you made the cake, you'd get the same answer. But we know the square root of 16. It's 4. So I'm just going to replace that with a 4. And we get 20. Done. I already know the square root of 16 is 4, so I don't necessarily need a cake for that. I'll use cakes for the ones where I don't know the square root. Okay. Well, let's look at the next one. Yeah. So yeah, because I know, this like says 5 times the square root of 16, right? And because I know the square root of 16, I'm just going to replace that whole thing with the number 4. Just making a substitution. Is that okay? Yeah. All right. Next up, I've got cube root now. Cube root of 9. Cube root of 6. Now, if you would like to, you can put a coefficient on both of them if you want. It's 1. If you'd want to do that, that's fine. Coefficient times coefficient, that's 1. Cube root of 54. Now 54 is not a perfect cube, so we got to go make a birthday cake. Easy. 27, 3, 9, 3, 3, 1. With my birthday cake, I'm just going to drop that 1 at this point because it's 1, it's a coefficient of 1. I don't need it. Cube root of 2 times 3 times 3 times 3. Because it's a cube root, just like on our warm-up, we're going to circle groups of 3. Circle it up. And I get 3 times the cube root of 2. And a lot of you guys on your warm-up, I was seeing like a little bit of struggle, like where does that 3 go? You just kind of put it in the elbow of the radical here. You need to put it there so it doesn't look like it's an exponent. You know, I'm going to really nestle it down in there. Okay, so essentially you multiply them together and then you simplify. Coefficient times coefficient, radicand times radicand. All right, let's look at the next one. Moving right along. This one has both coefficients and radicands, so I'll do coefficient times coefficient. I'll get a 15. Radicand times radicand. Now within the radicand, I've got numbers, you know. I've got 12 times 6, that's 72. X times x is x squared. Here's one of my problems like we did last time, right? I want to simplify that, so I'm going to make a birthday cake for 72. 18. That's called my prime factorization of 72. If you ever want to check your birthday cake, you can always just take a calculator and multiply together 2 times 2 times 2 times 3 times 3. You should get 72. All right, and I will do 15. And then I'm going to list out all of my factors of 72. 2, 2, 2, 3, 3. x, x. Circle into pairs. Okay, I got a 15 outside. I'll bring out a 2. I'll bring out a 3. I'll bring out an x. Only thing left behind is the 2. And then we're just going to multiply all this together here. This is identical to what we were doing last class. No, this is not a new strategy. This is just simplifying the radicals. What we're really adding today is the first step. Multiply them together and then simplify them. 15 times 2 times 3 is 90x. Square root of 2. I'll put that over here. All right. Now before we do the next one, just take a look at the next one. Look at the structure of that problem. Look at the structure of the problem. What do you think we have to do to multiply that? Yeah, distribute. It looks like we're going to distribute. That's exactly what we're going to do. So we're going to actually end up doing 2 multiplications, because think about when you distribute a problem that looks like this, and you multiply these together. You have to do 2 multiplications. First you do 2 times x, and then you do 2 times 3, and you join them with whatever sign is in the middle. We'll do the same exact thing here. It just seems more complicated because we're just not used to working with radicals so much. But we're just multiplying numbers together, okay? Distributing. All right, we know number times number, radical times radical. Now, I actually left a little bit of space there intentionally because I think what makes this problem a little challenging is this 2 here. Because we're going to multiply 4 square root 10. That's one number, 4 square root 10. We're going to multiply that with the 2. And it's like, well, is the 2 a coefficient or is it a radicand? You know, I don't see a radical. It makes it, at least for me, I'm like, I get a little bit confused. So think about that 2, it's like 2 with no square root. It's almost like that's an empty square root there. If you want to put a 1 under it even, you could, right? So the 2 is going to be multiplied with the 4. Coefficient times coefficient. So we get 8 square root 10. Okay, so if it helps you, you know, earlier when we didn't have a coefficient, we would put a 1. If you don't have a radical, you can always put like an empty radical symbol just to remind you that that's the coefficient. Multiply it with the other coefficient. 10 times that. All right, next we're going to do coefficient times coefficient. So that's going to be 12. Radicand times radicand. 12 square root 20. I did 4 times 3, that's the coefficients. And I did the radicand times the radicand. Okay? All right. And put a plus sign in the middle, just like we do when we're distributing. Just like this. We're going to put a plus sign in the middle because that's what you do when you distribute. Last step is to simplify if you can. If I make a birthday cake for 10, this is not going to take me anywhere, right? I can't simplify the square root of 10. So just leave it. But 20, if I make a birthday cake for 20, it's 2 times 2 times 5. So that one I actually can simplify. So I'll do 2 times 2 times 5. Circle a pair of 2's. 2 out, so that's 24 square root of 5. Now, we're not going to get to adding until next class, but it's for me where the pitfalls are with adding. I know why adding is the hardest one. It's because we just desperately want to add something like that together. But I'll just say it, I'll just give you a little preface today. You can only add radicals if the radicands are exactly the same. So square root of 10 and the square root of 5. You can't put them together. They're not like terms. Okay, so we just leave that. That's done. I multiply and then I simplify. And that's it. I'm not going to add them together. Because you can't. That's what's frustrating, I think, about adding is some of the problems you're like, well, I can't add those. All right, let's look at the next one. What does this look like we're going to do? FOIL or the box method? Exactly. If you're FOIL, you can do FOIL. If you're box method, you can set this up in the box method. I'm FOIL, so I'm going to do FOIL. 2 times 2, first times first, that's just 4. Outer, we're going to do 2 times 4 square root 3. Now again, if it helps, you can just say, well, that's an empty radical there with the 2. So it's going to be 8 square root 3. For the inner, I'm going to get minus 8 square root 3. And for the last, I'll do radicand times radicand. Sorry, coefficient times coefficient, negative 4 times 4. Radicand times radicand. Okay, these will cancel each other out. Positive 8 square root 3, negative 8 square root 3. Gone. So I'll bring down the 4. If you want to make a birthday cake for 9, you can. That's fine. But what's the square root of 9? 3. So we don't need a birthday cake if we already know that it's a perfect square. I'll just replace it with a 3. 16 times 3 is 48. 4 minus 48 is negative 44. All right, last one. This one looks the worst, but it's really not. Okay. Coefficient times coefficient, radicand times radicand. Coefficients are negative 2 and 3, so that's negative 6. Radicands, 18 times 2, 36. X times x cubed. This is where I think we need to take a little pause. Okay, it is. Let's take a little pause though. This is something that we haven't done in class yet this year, and multiplying like x times x cubed or y cubed times y divided squared. So let's just pause for a second so we remember what this means. You learned exponent rules, probably in geometry too, but definitely in algebra 1. And you learned that if you want to multiply, like what we're trying to do here, let's just make sure we see this. We're trying to multiply x and x cubed. So I think a visual approach is always good. I'm trying to multiply x and x cubed. So that's x times x, x, x. What's that? X times x times x times x. That's x to the 4th. Okay? That's going to be x to the 4th. And then when I want to do the y's, again, visual approach here. Oopsie. That's not going to work. It's not a highlighter. How about this? When I want to do the y's, I'm doing y cubed times y squared. So y cubed times y squared. Y cubed times y squared. That's y times y. What's that? What is it? You're adding. Yes. Y to the 5th power. Now, the rule that you learned when you were in Algebra 1 is that when you multiply, you add the exponents. But sometimes it's not enough for me to just say that, right? You got to see it. You don't multiply these. You add them because this means 3y's, this means 2y's, and that's a total of 5y's being multiplied. Yes? How did I get the 4? Okay, so this, I'm doing x times x cubed, right? The first one has an x, second one has an x cubed. So x times x cubed means x times 3 more x's. That's a total of 4 x's being multiplied. So that's x to the 4th. If you want to apply the rule to that, it still works because this is x to the 1st power, and you add the exponents. 1 plus 3 is 4. So the rule also works. Yeah, take the pass. That's there. Okay, so it's worth a little pause on that. Now, this we've seen, we were doing problems like this one last time, where it's like, okay, let me put this in here. X to the 4th, y to the 5th. I'm going to go over here. I'm going to make a little birthday cake for 36. Oh, 3. 36 is 2, 2, 3, 3. X, 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 X. Y, 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 Y. Again, if you can find a shortcut for this, I'm not opposed to it, but I'd rather you get it correct. So that's why I write it out. Circling pairs. Boom, boom. Pairs of Y's. Bring out a 2. Bring out a 3. An X, another X, a Y, another Y, and then one lonely Y left inside. So that's negative 36, X squared, Y squared, square root of Y. Okay. All right. Now, what I would like you to do, pick one person at your table. Pick one person to come up and get 2 whiteboards, 2 markers, and 2 erasers. Pick one person at your table to come and get 2. Not one for every person. Just 2 whiteboards, 2 markers, 2 erasers for your table. Come on up. Yeah, sure. See, this is the benefit of doing it on paper, actually, because I still have it. I didn't erase it, you know? Is that good? Is that the one you want? Yeah. Sure, sure. Okay. It doesn't matter who starts this time. We're doing something a little different. Similar to Save and Scribe, but not Save and Scribe. It's called Rally Coach. You guys need to do that? Oh, you're helping. Excellent. Oh, I can stop this. I can pause this. All right. Now I have to remember to unpause this. That's all right. Let's take a look at the next one. Now, this is the 2 cube roots, cube root over a cube root. Before we start talking about the cube roots, we've got some coefficients here. We've got 6 over 2, right? The rules for numbers have not changed, okay? Just because we're adding new methods into our heads about radicals, the rules for numbers are the same. What's 6 over 2? 3. Said we're not stopping. It's 3, you guys. Okay, it's 3. We all agree, right? 6 divided by 2 is 3. So let me just write down 3. If you want, you can write 3 over 1, because that's the same thing, right? If you want, but you can also just write 3. I'll leave that up to you. Our rule says that we can take these 2 cube roots and like put them all together into 1. So I'll have 6 x to the 8th over 16x squared. Now this is no K form. This is not like an easy problem. I realize that. Let's take one bit at a time. How do I simplify 6? Let's do the number part. 6 over 16. What's 6 over 16? 3/8. Divide both the numerator and the denominator by 2. 6 divided by 2 is 3. 16 divided by 2 is 8. So that. Let's look next at. We're gonna use 3/8. I'll write it down when I sit down. How about that part? X to the 8th divided by x squared. X to the 6th. Now, if you're like, wait, we're dividing. Remember, x to the 8th, that's not what I wanted. X to the 8th means this, 6, 7, 8. over 2x's, and then you cancel out 2 of them, leaving 6x's. The exponent rule that you learned in Algebra 1 was subtract. If you're dividing, you subtract the exponent. So it's x to the 6. So we got 3/8 for the fraction part, and then we got x to the 6th. X to the 6th. Okay. 3/8, and then x to the 6th, we can put that as part of the numerator. Now the reason I chose a kind of challenging problem here for this example is because I really want you to see this next part. Okay? I really want you to see the next part. I'm going to move the paper over a little bit. All right. If you are allowed to take 2 radicals and put them together as 1, you are also allowed to take 1 radical with a fraction in it and take them apart again. If you can go this way and put them together, you can also take them apart. And to finish simplifying this problem, that's what we have to do. And you have to do that sometimes. We've got to take these apart again. And the reason we want to do that is because we know what the cube root of 8 is. Right? 2. So the denominator is going to be a 2. Let's come over here. I know, the reason I'm doing this is because I know what the cube root of 8 is. It's 2. And I can simplify this numerator. And I'm actually going to use my eraser to save a step here. X to the 6th means 6x's, right? I'm going to take my triples. If you prefer a birthday cake method for the cube root of 8, that's fine. You'll see it's 3 2's. It's just 2 times 2 times 2. But I'd also like us to just know cube root of 8 is 2. Bring an x out. Bring another x out. 3x squared. Cube root of 3. I had 2 groups of 3, so I'm going to bring an x out, bring another x out. That's why I have x squared. 3 is all stays under the radical. Okay, so that's going to be, you'll see that today in a couple of our problems that we'll do after lunch. Yeah, go. Okay. You'll see that today, where you're going to put the radicals together, and then you're going to have to take them back apart in order to simplify. Just Miriam's just got to go somewhere. Everybody else is going at the bell. You got 2 more minutes till the bell. Yes? What? A screwdriver? Oh, flathead screwdriver. I mean, not in my current possession.
I can't, no, it won't open. I need it to open.
That might work, actually.
Do it. I can't open it.
Flathead. Oh, you're going to put it and you're going to twist it.
So put it in there and pop it out.
Or you got to have really good hands. What about this? This is flat. You put that in there. Yes. And then maybe twist it. Yeah, this is a engineering problem right now. I think so too. Try twisting. Twist. That's what I do. Oops. See, here's the problem with me making the videos. Whoever's watching this at home, they're involved in this conversation.